Welcome. Today we'll solve a fascinating problem about airplane navigation in the presence of wind. This is a great example of vector addition in real-world applications. Let's understand our problem. We have an airplane with an airspeed of 580 kilometers per hour. The plane needs to fly in a straight path that's 38 degrees north of east. However, there's a steady wind of 72 kilometers per hour blowing from the north. Our task is to determine in what direction the plane should head to maintain its intended path. Let's solve this using vector addition. The key is to understand that the actual path of the plane, or its ground velocity, is the sum of two vectors: the air velocity of the plane, which is the direction the plane is pointing, and the wind velocity. To solve this mathematically, we need to use the fact that the ground velocity vector is the sum of the air velocity vector and the wind vector. We can break this into x and y components. For the x component, we have vgx equals vp cosine theta. For the y component, vgy equals vp sine theta minus 72 kilometers per hour. Using these equations and the fact that we want our ground velocity to be at 38 degrees, we can solve for theta. After performing the calculations, we find that the plane should head approximately 35.2 degrees north of east to maintain its intended path. This problem demonstrates how vector addition helps us solve real-world navigation problems. The pilot needs to point the plane at a slightly different angle than the intended path to compensate for the wind's effect.